Hello everyone, my name is Jovan and I'll be presenting the main points of my literature review on fog computing and security. Firstly, I'll give a brief introduction on what fog computing is, followed by the three fog computing architectures that I've explored, which are hierarchical, edge-oriented, and lastly region-based fog architecture. I'll then talk about the limitations and security recommendations and end off with my conclusion. Fog computing is a decentralized computing architecture that brings cloud computing capabilities closer to the network's edge. This means that instead of relying solely on centralized data centers, it distributes processing power and storage across multiple devices located in the fog layer. Firstly, the three-tiered hierarchy of the hierarchical and heterogeneous architecture consists of a centralized unit at the top and aggregated sites and base stations with fog nodes in the middle, and lastly user equipment at the bottom. The centralized unit is responsible for global scale tasks that demand more computational power, while the middle tier is used to deal with region-specific tasks and also serve as an intermediary between the top and bottom tiers. Lastly, the user equipments are used for data generation. This approach allows for better scalability and flexibility by distributing different tasks across the tiers. Next, the edge-oriented fog layer places computational resources in the form of mini-cloud or cloudlets near the end user, reducing the latency and improving the bandwidth efficiency for computations. In the provided diagram, we can see that the cloudlets are placed closer to the end user devices, which provide lower latency between data transmissions. Through the fog layer, the various cloudlets are able to perform resource pooling to perform more complex operations, albeit not being as fast as the centralized fog node. Lastly, region-based fog layer focuses on a localized method to resource management by organizing fog nodes into regions, which are semi-independent geographical clusters. Each cluster has its own set of fog nodes that interact with one another to perform computational tasks together. There is a centralized node known as the delegated fog node in each region, which is a powerful device that is tasked with resource and trust management. It provides various security mechanisms such as RBTA to strengthen the fog architecture, which I'll be going through more in depth later. So some limitations of hierarchical networks include the resource constraints due to requirements of computationally intensive algorithms, latency issues due to the data transmissions between devices in different tiers of the hierarchy, and lastly, security issues such as trust management of devices and data integrity. For edge-oriented architectures, they face hardware limitations in individual mini-cloud centers and unable to perform computationally intensive tasks. However, the resource pooling feature helps to share the load by pulling together to perform the task, which slightly elevates the problem. The approach introduces some security issues as the microcloud centers can be vulnerable to cyber and physical threats. Complications of identity verification from moving edge devices is also another concern. Region-based approach aims to solve the security issues, however, in doing so creates computational overhead from all the mechanisms put in place, also making it much harder for the architecture to scale with larger networks. Learning from the security features of the region-based approach, there are three identified mechanisms which I believe could be utilized in the other two approaches to resolve security concerns. Firstly, the region-based trust-aware protocol provides secure communications within and between regions and also manages the trust relationship. The protocol's concept could be adapted to fit into the hierarchical architecture and the edge-oriented approach to resolve its trust and data integrity concerns. Next, the role-based access system handles permission management and data access prevention to restrict access based on certain factors, such as the user permissions. This can further enhance the security of not only the edge-oriented nodes, but also the base station and centralized nodes as well. Lastly, the location register database ensures secure and efficient handovers between the regions, and also ensures integrity and access rights from devices transitioning between regions, addressing the node mobility challenge present in most fog computing architectures. To conclude, fog computing addresses critical limitations of traditional cloud computing. However, it also faces significant security challenges. Therefore, it is crucial that the deployment of fog computing systems is accompanied by robust security measures to mitigate these risks. Thank you.